In this video, we are going to be going over compression members. So things like columns would be classified under compression members. Again, this is going to be in the AISC manual, and I'm using the 15th edition, which is the blue manual. So the chapter that you're going to be using for the design of compression members is going to be chapter E. Now, like our flexural member section, chapter E also gives us a table user note. So table user note E 1.1 will direct you to the appropriate sections within chapter E to know which limit states you need to check. So this table is based on if your member has slender or non-slender elements. And you determine that by checking local buckling of your section. Now to do that, you're going to go to table B 4.1A. And again, remember when we were looking at flexural members, we went to B 4.1B, but just because we're looking just at axial compression, we're going to use B 4.1A. And so from that table, you'll pull off your lambda R equations, and you'll solve for lambda R for your flange and for your web. And then from your section, you can get your lambda for your flange and lambda for your web, which you're going to pull from table 1-1 for your I section. But again, if you don't want to pull those off the table, then lambda F is going to equal BF over 2TF, and lambda W is going to be H over TW. But again, you can just pull those values from table 1-1. Now, if your lambda F or lambda W are less than lambda R F or lambda R W, then you have a non-slender section. But if they're greater than lambda R, then you have slender elements. And again, that's just going to help you when you go to this table user note up here to direct you to the appropriate section within chapter E. Now, most of the time, you're going to either be looking at doubly symmetric I shapes or doubly symmetric HSS shapes. And so for these ones, if they're hot rolled, they typically don't have slender elements. And so for your eye shapes, that's going to direct you to section E3 and section E4. And for your HSS, it's going to take you to E3. So if we take a look at section E3, it'll give us the equation for our axial strength as being Pn equals FCR AG. Now, AG is just your gross area of your section. And again, that's tabulated at the beginning of your manual, which is table 1-1 for I sections, and HSS are just a couple tables after that. Now this FCR value, there's a couple different equations for this, and you're either going to use equation E3-2 or E3-3. And what's going to determine which equation you use is this ratio right here, your LC over R, whether it's less than or greater than 4.71 times the square root of E over Fy. So if LC over R is less than this right here, then you're going to use this equation. Otherwise, you'll use that equation there. Now, just to point out, LC is actually equal to K times L, and your K value is going to come from table C-A-7.1, which is on page 16.1-570. So you can pull off your K value from there, and your L is just your unbraced length. And for your R in that ratio, you're going to use the minimum of Rx or Ry. And again, those are tabulated at the beginning of the manual. So table 1-1 for eye shapes. Or if you're looking at HSS, it's just going to be a couple of tables after that. So your FCR is, once you figure out which equation you're going to use, it's based off of this FE value, which is your elastic buckling stress, and that you're going to determine that from equation E3-4. And that equation is pretty straightforward. It's just pi squared E all over LC over R squared, which we know all of that information. And so then once you know FE, you can plug it into your FCR equation, get FCR, and then plug it into this equation. It's also important to note that phi in these cases are going to always be 0.9. And again, once you check section E3, then you'll have to go to section E4 and check that for your flexural torsional buckling. And again, the equation is going to be the same, Pn equals FCRAG. And again, your FCR is going to be based off of FE. This FCR, you're actually going to use these same equations, but your FE is going to be the thing that changes. And again, there's a couple different ways that FE is calculated, and it's based off of your section geometry. So section A is going to be for symmetric members. B is going to be for singly symmetric members. C is going to be for unsymmetric members. So once you calculate your FE, you can actually determine from that point if which is going to control. So if your FE ends up being greater, if your FE from section E4 ends up being greater than your FE from section E3, then you know that section E3 is going to control, and you actually don't need to finish calculating your PN because you know that your PN for E4 is going to be greater than your PN for E3. And so you know that this one is going to control anyway, so you don't need to calculate that one. Just to point that out. However, if your FE from E4 ends up being less than your FE from E3, you know that this one's going to control, so you got to finish calculating out your PN, and that's going to be your design compression strength of that section. Now, it's also important to note that if you go to table 4-1A, it'll actually give you the compression strength of your members. So this is for I shapes. And then if you go a couple pages later, if you go 4-1B, this is because FY changes to 65 KSI, where up here FY was equal to 50 KSI. And again, if you keep going and you look through these tables, you can see that it gives you a couple different options for shapes. So for your HSS, you're going to be looking at table 4-3. And again, it tabulates for you the compression strength. So if you have to do it by hand, this is the procedure that you follow for up here. However, you can use these tables to check yourself, but once you get out of school and into the field, you can just use the tables to save time and to be more efficient. Now, if you have any questions about this or questions about a particular homework problem, head over to our homework help page. Or if you want to sit down and go through one of these examples, head over to our tutoring page and schedule an appointment.